This is the homework help video from worksheet 8-7 on problems 5 through 10. The directions state solve each equation for the exact value of x. A calculator is not permitted. So we want the exact value of x, and we are not using the calculator. Number 5, the natural log of x equals 3. So this is a log equation. In order to solve a log equation, typically we need to rewrite it in exponential form. So if we're talking about, log base e of x equals 3, this is e to the third power should equal x. So e to the third power equals x, and you'll see we actually have already solved it. Remember, you can always check these on your calculator as well, right? You can find your value of e to the third, which is about 20.086. And then you could also take it in and go into the graphing part or the solver, however you wish to do it, and solve it graphically, then find your answer. And you'll see here I get that 20.086 as well. So x equals e to the third. All right, number 6, we have an exponential equation, e to the power of x equals 200. I'm going to get my x out by going ahead and taking the natural log of each side. Don't forget to do both sides. So when we do the natural log of e raised to the power of x, we know that x comes down as a coefficient, and then the natural log of e is 1. So we're left with x equals the natural log of 200. Number 7, we have 5 times the natural log of x plus 1 equals 4. Again, a log equation, but in order to solve it, we need to isolate the log. We need to have just the natural log of whatever we have there, like our value of x plus 1. So our goal here would be first to get rid of our 5. So since it's being multiplied, we'll divide each side by 5. We now have the natural log of x plus 1 is equal to 4. And then since this is like base e, we'll say e to the fourth power equals x plus 1. And then we can isolate our x by subtracting 1 from each side. We have e to the fourth power minus 1 equals x. That is our exact answer. Okay, so looking at number 8, we have e to the power of x plus 2 plus 20 equals 100. So again, we need to isolate our e raised to the power of x plus 2 in order to be able to solve this. So let's just go ahead and get rid of our 20 by subtracting it from each side. We have e to the power of x plus 2 is going to equal, is that 80, I believe? And now we need to take this and get the x out, so we're going to have to take the natural log on each side. That being said, right there is our exponent. We're going to move it out in front, so it'd be like times 1, so we'll just leave it as x plus 2. That equals the natural log of 80, and then in order to isolate x, we'll subtract our 2 to get x equals the natural log of 80 minus 2. Please make sure you don't actually subtract 2 from 80. That would be incorrect. Okay, so natural log of 80 minus 2. Don't do natural log of 78. All right, I forgot to just box this one in. Let's go on to 9. It says the natural log of e plus the natural log of x equals 4. You could look at this one in a couple different ways. Some of you may want to think about combining our log statements together. But what I'm going to focus on is the natural log of e. I already know the value of that. So if I know the value of the natural log of e, I'm going to go ahead and just change it to its value, right? We know that's 1. So it's 1 plus the natural log of x equals 4. I'll just subtract my 1. So the natural log of x is now equal to 3. And since it's like base e, e to the third power should equal x. And that is our answer. Okay, next one. Number 10, we have the natural log of the quantity x plus 4 minus the natural log of x equals 2. And on this one, since I have two logs on the same side, but I don't know the value of either of those logs, I'm going to combine it into one log, right? So since we are subtracting the two logs that have the same base, we can use the quotient property of logs, which just means it'd be the same thing as the natural log of x plus 4 divided by x. That still equals 2. And since it's a log, we need to turn it into its exponential form. So e to the second power equals our value. So e to the second power equals x plus 4 over x. Now there's still a little bit more that we have to do on this one. So in order to get that x out of the denominator, we're going to need to multiply both sides times x. So what we now have on this one is e squared x equals x plus 4. So let's get our x's on the same side. Subtract your x across. We have e squared x minus an x equals 4. And now we can use factoring to get it down to 1x, right? Our greatest common factor on the left is x. So x times the quantity of e squared minus 1 should equal 4. And then to isolate x, we'll just divide. So x equals 4 divided by e squared minus 1. And that is our exact answer. So that's problems 5 through 10 from worksheet 8-7. If you have additional questions on any of those, please let me know.